Hello, my dear students. It's my pleasure to meet you today again. Today, inshallah, we are going to complete our lesson, follow angle bisectors, and if we have time, we will study applications on proportional parts. So concentrate with me here. Yes. The last lesson, we have talked about triangle ABC, and if we have a bisector like that, and this point called D, okay, we have found that we can find the length of AD. AD here equals square root of AC AB but multiplied minus CD DB. Okay, if we have the bisector from inside here, from interior bisector of the angle A, the length of AD, which is the bisector, equals AC the square root of AC multiplied by AB minus CD multiplied by DB. And we have the bisector, if it is bisector exterior one, if we have a triangle like that, if we expand this part, okay, we have ABC here is a triangle called this point D, and we have the exterior bisector here, and we want to find the length of the bisector AD. The length of the bisector AD here equals square root, put minus here, we will start with BD times DC. And after minus here, AB times AC. So if we would like to find the length of the bisector from exterior or in exterior angle here, we will multiply BD times DC minus AB times AC, but inside the square root. Okay, let's go to an example here. If we have a triangle like that, and this is a bisector, triangle called ABC, and call this point D, and we have the length of sides. AC equal 9 centimeter, AB equals 15 centimeter, like that, and CD equals 6 centimeter. And the request is the length of BD of line segment BD, this one, and also the length of line segment AD, which is the bisector here, AD. We know from the last lesson that we will applicate the bisector rule, AB over AC here equals BD over DC. And we have the sides, a length of AB equals 15 over AC equal 9. BD, we don't know it up till now. CD equals 6 centimeters. By using cross multiplication here, we will find that BD equals 6 multiplied 15 over 9. And the answer will be 10 centimeters. So we have BD now equals 10 centimeters. It's very easy for you. And you would like to find out the length of AD. We have AD here. We already know the rule that by which we will find the length of the bisector, the interior bisector of the A. AD equals AB multiplied by AC minus BD multiplied by DC. We will substitute and we will find that we can write here 15 multiplied by 9 minus 6 times 10, and the answer will be 5 root 3 centimeter. Okay, it's very easy for you now. Let's go to another example here. We have an example here. If we have a triangle like that, and we'll expand this part, we have the triangle ABC now, and D is this point, and this side, which AD is a bisector of the exterior angle A. If you call this point F, okay, we have AB equals 8 centimeter, BC equals 7 centimeter, and AD equal X centimeter, and AC equals 6 centimeter, and CD equals Y plus 2 centimeters, and the request is find X and Y. Our solution, we have here exterior line, which is AD, and we know the rule. If we have exterior bisector, then we will divide AB by AC, AB here over AC equals BD, look carefully, BD, and return back to DC, BD over DC. So AB equals 8 over AC here equals 6. BD, we know that we have 7 plus Y plus 2. We can write it as Y plus 9. DC equals Y plus 2. And we will use cross multiplication now to find the Y length. So 6 multiplied Y equals 6Y. 6 multiplied by 9 equals 54. 8 multiplied by Y equals 8Y. 8 multiplied by 2 equals 16. And we have Y in the left side and 8Y in the right side. And we have to collect Y in one part, on one side. We can transfer 6Y here to here. We'll get 8Y minus 6Y. And this side, we have 54 already from here, minus 16 because it transferred to other side. Okay, we have 2Y now. 54 minus 16 equals 38. And if we divide this part, we divide 38 by 2 here. Then Y will equal 19 centimeter. Okay, Now y equals 19 centimeter, and we can find the length of CD totally. Now y equal 19 plus 2, so it is 21 centimeter. And you would like to find out the length of x. X is the bisector, is the exterior bisector itself, and we know the rule. X here equals square root, we put here minus square root of what? BD. BD now equals 7 plus 21, so it's 28. We write 28 multiplied by DC, which is now equals 21 centimeters, minus AB times AC, 8 multiplied by 7 multiplied by 6. So after calculating, x will be 6 square root 15 centimeters. Okay, we have the rules. We have the rule to find the bisector here, and we used it to find out that x equal 6 root 15 centimeters. Okay, my dear students, we now will go to the converse of the bisector theorem. We know that if we have a bisector, we use the relation between the sides. They will be proportional. But if the sides will be proportional, what we deduce? We will do that we have a bisector here. So look carefully with me. If you have a triangle like that, here ABC is a triangle, and we have a side here, we called it BD, and we have the relation that AB over AC, AB here over AC equals BD over DC, BD over DC. Then we deduce what? We will deduce that AD is the bisector of the angle A. It's now interior bisector. Look carefully again. If it is given, or you can deduce that AB over AC equals BD over DC, then directly you can deduce that AD is the bisector of the angle A. It is the converse of the last theorem. And even it is an exterior, we can deduce also that the line of the exterior bisect also. If we have a triangle like that, this is A, B, C also, and D is the point of bisector here, and it is here. And if we have AB over AC like that, okay, if we have AB over AC equals BD over DC, then we will deduce that AD is also the exterior bisector of the angle A, of the exterior angle A of the triangle ABC. So if we have, again, if we have AB over AC equals BD over DC, we will deduce directly that AD bisect the angle A, but from exterior. Okay, so we will find an example here. Okay, look with me to the second example. We have a figure, a quad like that. This is a quad. and we have the diagonal CA, and we have DE. This is D, A, B, C, and ED joined here. We have a bisector in the triangle CDA, which is DE bisect the angle D, and we have DA equals 6 centimeters, DC equals 4 centimeters, CB equals 5 centimeters, and AB equals 7.5 centimeters. The required proof is that the ray BE here bisects the angle B. The request is to prove that BE bisects this angle. We know that if you want to prove that BE bisects the angle B, we must prove that BA over BC equal BAE over EC, or if we start from this part, we must prove that BC over BA equals CE over EA. We will use the given parts here. We have DA equals 6 centimeter, DC equals 4 centimeter, as you see, and we have DE is a bisector, is the interior bisector of the angle D in triangle DAC. So we say that since DE bisects the angle D in triangle DAC, therefore DA over DC equals AE over EC, and we have DA here equals 6 centimeter over DC equals 4, and if we simplify it, it will be 3 over 2 in simplest form. Okay, that's one. And we transfer to the triangle CBA. In triangle CBA, we try to find out the ratio BA over BD. BA here over BC, BA over BC equals 7.5 over 5. And by using your mind or your calculator, you will find out that this ratio in simplest form will be equal 3 over 2. From the relation 1 and relation 2 here, we notice that AE over EC, look carefully, AE here over EC will be equal BA over BC, BA over BC in triangle ABC, and this, because they are equal, the same ratio here, 3 over 2, and this proves that BE bisects the angle B. Why? Because BA or AB over BC, we proved that it is equal AE over EC. Okay, it's easy for you. And we have another example here. Yes, we can discuss about another example. This is the converse of the last theorem. The last theorem says that if we have a bisector, then we will deduce that some sides are proportional. But now we have some sides are proportional, so we will deduce that it is a bisector of the angle in triangle. So let's go to another example here. If we have a triangle like that, okay, triangle ABC, and we have AC here, such that CB equals, let's say that it's D here and C here. C is the midpoint of BD, so we can say that BC equals CD. And we have also that this side, which is AC, equals this side, which AB, so ABC is an isosceles triangle. And we have a bisector here like that. We call this point is E. So we have here BE is the bisector of the angle B in triangle BAC. And we have also EF. This is F and this E is parallel to DC. And the request is to prove that CF bisects the angle ACD. Okay, prove that CF bisects the angle ACD. Solution. Look carefully here. We will use the given here. We have BE bisects the angle B from inside or interior bisector. We say that BE bisects the angle B in triangle ABC. So we will deduce that AB over BC equals what? Equals AE over AC. Let this is equal one relation or one proportional or one equation, and we will transfer to this is E and this is EF parallel to CD in triangle ACD. We say that since EF is parallel to CD in triangle ACD, so we will do that AE over EC from parallel equals AF over FD. AF over FD. And this is the equation number 2. Look carefully to these two equations. We have here this ratio AE over EC, and this one also AE over EC. They are the same, of course. So we can deduce that AB over BC equals the ratio AF over FD. When we look at AB here, AB over BC, we're still in the triangle ABC. But in fact, we would like to transfer to the triangle ACD to prove that CF here is a bisector of the angle ACD. But we have a given here that BC equals CD. So we can put CD instead of BC. So we'll write BC here, okay, instead of CB. Okay, we put CD here instead of CB, and instead of AB we put AC. Instead of AB we put AC because they are equal in the given of triangle, that the triangle ABC is an isosceles triangle and AB equal AC. So we can put AC instead of AB and DC instead of CB here, equal AF over FD. So now we have that AC over CD equals AF over FD. So it's clear now that we can say that CF bisects the angle ACD. We have used that the bisector here of triangle ACD in this equation, and we use the parallel EF parallel to CD in this triangle to get the second one, and we deduce that we have two equal ratios, then this ratio equals this ratio here, and because BC equals CD, so we put CD here instead of BC, and because AB equal AC, so instead of AB we put AC. So we deduce that AC over CD equal AF over FD, and it is the ratio that prove that CF is the bisector of the triangle of the angle ACD. Okay, let's go to another example here. We have an example here. Look carefully and concentrate with me. We have a triangle, but is not ordinary one. It is a right angle triangle here at A. So we have A, B, C is a right angle triangle at A, and we have also AD is a perpendicular to CB at D here, and we will join this side CE, and we have AB equals 6 centimeter here, AE equal 2 and 2 over 3 centimeters, and AC equal 8 centimeters. Okay, prove that CE bisects the angle ACD. Okay, we have CE. We would like to prove that CE bisects the angle C here. Okay, we have AB 6 centimeter and AC equal 8 centimeter, and this is a right angle, so we use Pythagoras theorem to find the length or the calculate or the length of BC. BC here, we have solution. BC here equal square root of AB squared plus AC squared, so it's 10 centimeter. So we have CB equals 10 centimeters now, and we would like to find out the length of AD. Remember, my dear students, that we have a perpendicular and a perpendicular from right angle. We write a perpendicular to BC. Yes, if you remember Euclid's theorem, we'll find that AD here from Euclid's theorem equals AB over AC, AB times AC over BC. So the answer will be AB here equals 6 centimeter multiplied by AC, which is 8 centimeters. BC here, we have found it, it's 10 centimeter. So the answer, the length of AD now, by calculating, we'll find it 4.8 centimeters. Okay? And we have ED. ED here equals 4.5, which is the whole length of AD. 4.8, sorry. Okay. 4.8 minus 2 and 2 over 3. So the length of AD will be equal 2 and 2 over 15 centimeters. Okay. Now we would like to find CD length. CD here from the right angle triangle here, ADC. It's AC power 2 minus AD power 2, but in square root. So it's 8 power 2 minus 4.8 power 2. So it's equal 6.4 centimeters. Okay, and we'll try to find CA over CD. CA here over CD equals 8 over CD equals 6.4, and the answer will be 5 over 4. It is the first ratio, and we have another ratio which is AE over ED over ED equals 2 and 2 over 3 over the length of ED, which is 2 and 2 over 15, and the answer will be 5 over 4. It is the same ratio as this one. We can call this one is 2. So we have now CA over CD equals AE over AD. They have the same ratio. So we just now that CE is the bisector of the interior angle C. Yes, it's a long question, but now, my dear students, yes, my dear students, let us take a break, take a small break, and we will back again. Don't go away. Okay. Hello again, my dear students. We will go to a fact here. If we have a triangle here, look carefully with me. Triangle ABC, and we have a bisector of A here and another bisector for C, intersect at the point M. Then if we join BM here, it's also another bisector. So all bisectors here, all bisectors of the angles are concurrent. What is the meaning of concurrent? Concurrent, that means that they will meet at one point inside the triangle here, and this point we'll call it point of concurrence of the bisectors of the angles of triangle. So if we have an example, if we have a triangle like that, ABC is a triangle, and we have a bisector here and another one here. This is a bisector of A and this is a bisector of B, and we have CM intersect AB at D, just a line segment, and we have AC equal 4 centimeter, CB equals 8 centimeter, and we have the whole side AB equals 6 centimeter here. This is the whole side of AB. Okay, so AB equals 6 centimeter, and the request is to find the length of the line segment AD. This is AD. Okay, we have here BM, a bisector of the angle B, and AM is another bisector of the angle A. So if the side here CD passes through M, and we say that M belongs to CD, if we have CD passes through M is the point of concurrence or the point of intersecting of the two bisectors here, then CD itself will be a bisector of the angle C. So we can deduce that CD is the bisector of the angle C, and we can deduce the relation of bisector here. If we have a bisector, then AC over CB equals, of course, AD over DB, and AC here equals 4 centimeter and CB equals 8 centimeter. AD we don't know it, and we can call it X over DB. We don't know it, but we know that AB here equals 6 and AD we put it as X, so DB equal 6 minus X. Okay, so DB equals 6 minus X here, and by using cross multiplication we will find out the length of X, which is AD. So let's go. 8 times X equal 8X equals 4 times 6 equals 24 minus 4 times X equal 4X, and we can transfer X here, negative 4X here. We have here 8X plus 4X equals 24, and we can add 8X to 4X equal 12X equal 24, so X equals 2 centimeters, of course. X equal 2, that means that AD equals 2 centimeters. Okay, and we have found the request here. Okay, my dear students, by this example we have finished the lesson of the converse of the bisector theorem, but now we will move to application on this part of lessons, which is circle. We have circles, many circles. We have parts in it, so concentrate with me to find what is this lesson. And I have already drawn some of circles here. Okay, let's concentrate here. If we have a circle like that, this is a circle, and we have, of course, the center of circle. We called it M. and we have a point here. Let it A. Of course, MD here is the radius of the circle, but this point lies some centimeters away of the circle or outside the circle. So MA here, it is the length of the distance between the center of circle and the point A. We will call that lesson is the power of the point A. Power, we call it or put it P. The power of the point A related to the circle M. This is the name of the lesson of today. The power of the point A related to the circle M. Okay, we have a rule here. P of A related to M, or P of A directly, equals the distance AM power 2 here minus the radius power 2. The radius here is MD. This point A maybe lies outside the circle, and in this case P of A will be greater than 0, and maybe A lies on the circle itself like that. So P of A equals 0, and maybe the point A, we can say A dash or A double dash. If A lies inside the circle, so the power of the point A related to M, of course, less than 0. So look carefully. We have the power of the point A in 3 types. We have this one, power of the point A positive, so it's outside the circle, equals 0 like that, so it is on the circle. We can call it A dash, and D, this one is A double dash. If we power the point A double dash less than 0 or negative, so it lies inside the circle. So let's see some examples on it. We have already another circle for you to keep your time. If we have here a circle, look here, we have a circle here, and its diameter of this circle equal 12 centimeter. This is the circle M, and we have diameter equals 12 centimeter. So here it's 6 centimeter, the radius, and the other radius equals 6 centimeter. And we have a point, maybe point outside or on or inside circle. Let this point will be B. This one equals C. And we have a numbers. We have power of a point A equals 13. Another power of the point A equals 0. The third one equals negative 11. And the request is, tell the position of the point A in this case, and in this case, and in the third case. We know that this power of the point equal 13, which power positive number greater than 0. So A here lies outside the circle. The power of the point A equals 0. That means that the A here is on the circle. And P of A equal negative 11, which less than 0 or negative number. So A here lies inside the circle. Okay, and he would like to calculate the length MA. In the first case, let A here, okay, and radius equal 6, and MA we have to calculate its length, and we have the power of the point here equal 13. So we will applicate the rule that says that the power of the point A related to M equals AM power 2 minus R power 2. The power of the point A equals what? AM here, we don't know it, so it's unknown, but radius equals 6, so it is 36. And we have known that power of the point A equals 13 here, so 13 equals AM power 2 minus 36. Okay, so AM power 2 equals 13 plus 36. We have transferred negative 36 here to positive. So AM power 2 equals 13 plus 36, and 3 plus 6 will be 9, 1 plus 3 will be 4. So by taking the square root of the two sides here, we will find that AM equals 7 centimeter. Okay, by the same way you can find the AM, the length of AM in the second one. If we have AM here because A, power of the point A equals 0, so A lies on the circle itself. So MA equals what? Of course, MA equals the radius, so it equals 6 centimeter. But if you want to find or to calculate MA, if A here lies inside the circle, we will apply this rule and we'll find AM here equals 5 centimeter. Okay, let's go to another example here. We have already a circle here, and let's draw here a tangent. If we have a tangent here, AD, and we have AC like that, we have here put B, and this is the center of the circle, and we have also R, the radius of the circle here, CM equal R, and MB equal the other R. We know that AD power 2 from the previous studying, AD power 2 equals AB here multiplied by AC. Okay, so is it has a relation with the power of the point? Of course. The power of the point A related to the circle M will equal also AD power 2. It's very important relation for us. It's very important to solve some equations for us if you would like to find AD or power of the point M. And also we have the power of the point A related to the circle M equal AB multiplied by AC. Okay, let's move quickly to another relation. If we have a circle like that and we have AB here and CD, we have an E here, we know that AE times EB equals CE times ED from the previous lesson. And we here the power of the point A equal negative AE multiplied by AB, and also the same power of the point A equals negative CE times ED. We have here two important equations to find out any length, side length of these. If we would like to find CE, ED, or the power of the point, we will solve many equations. So, my dear students, we have now completed the geometrical parts, Unit 4, and inshallah we are going to, in the next periods, we will go to exercises on it, and we have only one lesson on trig. So until we meet again next week, inshallah, goodbye and good luck.